Hello and welcome to Math with Mrs. Havrilla. This is Mrs. Havrilla, and today we're going to be working on Unit 1, Lesson 8. In this lesson, we started a new section, and in this section, we started finding composite volume, or the volume of a figure which is made up of two rectangular prisms. So here you can see in the example, they've labeled the top of this figure A and the bottom of this figure B, because they're showing that this figure has been split into two pieces that are both rectangular prisms. And that's what we're going to be doing today. So I'm going to go ahead and start. And to do that, with number 1, to find the volume of this figure, I need to break this up into two rectangular prisms. There's two ways I could do that. I could cut the top off, or I could cut the side off. I'm going to cut off the top, and to cut off the top, I'm just going to show that using a highlighter. You could do this with a colored pencil. You could even do it with your pencil, just lightly shading in the box that you want to isolate or separate. In doing so, I'm now going to go ahead and label this one A, and this one down here is going to be B. In order to find the volume of this figure, I have to find the volume of A, I have to find the volume of B, and then I have to add those two volumes together. So what I'm going to do is I'm going to make a section for A, I'm going to make a section for B, where I'm showing my work. Now for A, I could do length times width times height to find the volume of A, but when I'm looking at this, I noticed that I could just count it. So that's what I'm going to do. I'm just going to count how many I see. I see 1, 2, 3, 4, 5, 6 pieces here. So the volume of A is 6. Now I'm going to find the volume of B. To do that, I'm going to do my length times my width times my height. Finding the length, 1, 2, 3, 4, 5, 6. My width, 1, 2. My height, 1, 2, 3. 6 times 2 times 3. I know that 2 times 3 is 6, so then I'm going to bring down this second 6 and get 6 times 6, which is 36. The volume of B is 36. Now, what I need to do is I need to add together my two volumes, the volume of A, the volume of B. So 6 plus 36, and that's going to give me 42 as my unit, or as my volume, and that's a cubic unit. I'll go ahead and circle 42 as my answer. Number 2. Which expressions can be used to find the volume of the figure below? Select all that apply. So, I see lots of options here. Before I even look at any of this though, I want to look at my shape. When I'm looking at my shape, I can see that there's, again, more than one way to separate this. I could cut the top off of this prism, and in doing so, I would have a length of 4, a width of 3, a height of 3 for my first prism, and then for my second prism, I can just count that there's 8 up here. Or, I could cut off the front piece. But let me go ahead and look at what we've got going on the side. For A, it says I could do 3 times 3 times 3. So they're assuming that they have cut this in a way where they ended up with a side length of 3, a width of 3, a height of 3. When I do that, I don't see a length, a width, a height of 3 here. Now, I counted at the top instead of finding the volume, but let's go ahead and figure out what this would be. I see a length of 1, 2, 3, 4. I see a width of 1, 2. I see a height of 1, so 4, 2, 1. That seems to be correct to me, but I know that this is not correct because one of these side lengths can't be 3, has to be 4. Can't be A then. All right. Is there an option that would have that 4, 2, 1? I don't see 4, 2, 1 here. I don't see it here. I do see 4, 2, 1 in C. 4 times 2 times 1, representing that top prism, which means this one is correct. So then I'm going to go ahead and look at the first one. It has 3 times 4 times 3, and it does look like it would give me the correct volume. So that one is definitely going to work. Now let's figure out what's going on in the front here. So in the front, we're imagining that we're actually cutting off this front piece this time. So we have this back section and we have a front section. In the front, let me try to change my color up a little bit here. In the front, I have a length of 4. I have a width of just 1 here. And I have a height of 1, 2, 3. Okay. And then in the back, I can see the width is 1, 2. The length is going to be the same because you'll notice it's just as wide in the back as it is in the front. So my length is still going to be 4. My width is now going to be 2. My height is 1, 2, 3, 4. So I'm looking for something that looks like 4 times 1 times 3 plus 4 times 2 times 4. Here I have 4 times 3 times 1, so that one's right. And then I have 4 times 4 times 2. This one's correct as well. Perfect. If I look down here, I do have 4, 3, 1, which works, but this one does not work because where I should have 4 times 4 times 2, they have 4 times 4 times 3. So D is not going to be correct. Moving on to the back. Number 3, it says a cube-shaped container has a depth of 7 inches. What's the volume of this container? Well, right away, I'm seeing the keyword cube. When I see that keyword cube, a cube is like a 3-dimensional square. What do I know about squares? I know that all of the side lengths are the same. So if I have a cube, that means my length, my width, my height are all going to be the same length. And if I know that there's a depth of 7 inches, that means that length is going to be 7. So if I were to draw a picture of this, I would have my cube, which kind of resembles a rectangle here on the front. I'm drawing my sides, and I know that I have 7 as all of my lengths when I'm working with a cube. So let's go ahead and find the volume. 7 times 7 times 7. I know that 7 times 7 is 49, and I'll bring down this third times 7 to get 49 times 7. I'll set that up vertically. Seven times 9 is going to give me 63, so I'll place this 3, carry the 6. 7 times 4 is 28, and 28 plus 6 is 34, which means that my volume is going to be 343 cubic units. In fact, the units are inches, so we'll say cubic inches. Number 4. Kara made a figure that was 16 cubic units smaller than figure A below. It's asking what's the volume of Kara's figure? Well, to figure that out, let me go ahead and find the volume of figure A, and then I can think about what could be 16 cubic units smaller. To figure this out, I see that I have quite a few weird sort of pieces coming off. But if I highlight this straight across the bottom, it actually makes it one really big rectangle on the bottom and then a smaller rectangle on the top. For my bottom rectangle, I have a length of 1, 2, 3, 4, 5, 6, 7, 8, 9, a width of 1, 2, 3, a height of 1, 2. Okay, for my top rectangle, I have 1, 2, 3 as my length. I have 1, 2, 3 as my width, and I have 1, 2 as my height. Now all I have to do is find the volume of both of these rectangles and add them together. So I would start with 9 times 3 times 2. I know that 9 times 2 is 6, and I'll bring down that 9 times to get 54 as the volume of this bottom rectangle. Then I'm going to do the top rectangle where I've got 3 times 3 times 2. I know that 3 times 2 is 6, and I'll bring down that 3 times to get 18. All I have to do now is add together these two volumes. 54 plus 18. Well, 54 plus 10 is 64, and 64 plus 8 is 72. So the volume of figure A is 72. So what do I need to do? I need to know what's 16 cubic units smaller than that. So that means I'm going to have to subtract, make it smaller. 72 minus 16. I cannot do 2 minus 6, so I'll have to regroup here. I'll take from the 7 and make it a 6, and I'll take this 2 and make it a 12, and do 12 minus 6 to get 6. 6 minus 1 is going to give me 5. My answer is going to be B, 56 cubic units. And again, to do that, we had to find the volume of figure A, and then we had to subtract Kara's volume, which was smaller. All right, last we have some multiplication fluency here. Starting with 9 times 2, we're going to get 18. 9 times 4 gives us 36. 9 times 8 gives us 72. And then I go all the way up to 9 times 16, which I could break up into 9 times 10, which I know to be 90. 9 times 6, which I know to be 54. And then all I have to do is add those two numbers together. 90 plus 54 gives me 144 as my answer. Down here, doing my 8s times tables, I've got 8 times 2 for 16. 8 times 4 for 32. 8 times 8 for 64. And now I'm actually kind of noticing a pattern. I'm doubling each time. So I'm going from 2 to 4 to 8 to 16, which means I'm timesing by 2. So I could take 64 and times it by 2 in order to get my answer for 8 times 16. Well, 60 times 2 is 120, and 4 times 2 is 8, which means my answer is going to be 128. All right, that's all we have for today. So be sure to check in again next time for help with your homework.